or the theoretical, they're close enough, aren't they? Are any of these outliers when you roll a single die? Would anything be considered an outlier? Blake's saying no, I don't think so. Dave's saying no. How come? How come? Remember the rules of identifying outliers? If you have bell-shaped data within 2 standard deviations.
Right.
Don't have bell-shaped data. Shoot, check that one off. We looked at a box plot. There were no little things on the ends. Check. Remember the third way? I mentioned it. We said that it ties into the other ones. Percentage occurrence. What is an outlier again? Forget math. What is an outlier?
Something's beyond the norm.
Beyond the norm. Keep going, keep going, keep going. I love this. Beyond the norm. Keep going, Linda. I love that, Sandra. Good. It doesn't happen very often. That's what makes it an outlier, right? If it doesn't happen very often, that's what makes it an outlier. These happen 16, 17% of the time. That's hardly rare. If you throw a die and get a 6, you don't go, God, call my mom. No, because you rolled a 6. It's just as likely as the 1. Everything's equally likely. Is that believable?
Right.
Go, Candace.
You mentioned something about a 7% variance, and I think that's what says.
Oh, no. That's you have to put a plus or minus on these.
But doesn't that kind of say whether it's not an outlier too? Is because
If it will be outside of that. So in other words, put a 7% plus or minus on this. Is that within 7% of that?
But I think that's kind of why I see there not being an outlier too, is because they're all so close.
They're all within. Good for you. Yes, they're all. That's kind of what I'm getting at. Is these are essentially equal to that.
Yeah. So that's
Now,
why I don't see an outlier.
good for you, sister. Good. I want to go a little bit further than what you're saying right now. If that's okay. I want to show you guys a simulation I built that I think reiterates what you're talking about, Candace. What is